Welcome to the YC500i Microinverter and ECU Wi-Fi installation training. This is the first in a series of online training modules for the APsystems product line of microinverters and accessories and supporting software applications. The target audience for this video training session is solar array installation technicians who may or may not have experience installing solar microinverters and need to familiarize themselves with the potentially unique aspects of the APsystems YC500 installation. Before we get started on the actual training, let's take a few seconds to talk about getting yourself registered as an installer with APsystems. If you've not already done so, email APsystems Technical Services at emea@apsystems.com or fill out the registration form on the APsystems website to get yourself registered as an APsystems installer. Please be ready to provide the following information: company name, company address, company phone number, contact name, contact phone number, contact email address, and the name of your distributor. You'll not be able to set up your customers with online monitoring without being a registered APsystems installer, so it's critical that you get this done before completing an APsystems microinverter installation. Technical Services will send an email to the contact name provided once the registration process is complete and your installer account has been set up. Now, on to the training. There are three basic components that make up the APsystems microinverter system: the inverter, in this case the YC500, the Energy Communication Unit, or ECU, and the Energy Monitoring and Analysis Website, or EMA. The inverter's role in the array is to convert the DC power that is generated by the solar panel into AC power, which can be utilized by the power grid. The YC500 is a grid-tied microinverter. The YC500i also features integrated VDE certified relays, meeting safety requirements for countries around the world. The APsystems YC500 functions as two inverters, built into a single case, and has the following characteristics. It's a single-phase inverter, but given its architectural flexibility, it can also be used in both single-phase and three-phase applications. The YC500i operates at 50 Hz, 230 volts, has an IP67 enclosure, and operates with two independent MPPTs and integrates VDE relays. The maximum number of units per 110, 230 volt, 20 amp on a circuit is 7, or a total of 14 PV modules. The YC500 uses the Power Line Communication, or PLC protocol, to communicate with the Energy Communication Unit, the ECU, and while the warranty varies depending on pricing, it has been engineered for a design life of 25 years. The ECU collects and stores the performance data from each of the microinverters and sends it to the APsystems database so that the array can be monitored via the internet. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. The Energy Monitoring and Analysis, or EMA website, allows for 24/7 management and monitoring of the solar array via any web-enabled device, such as an internet-connected computer, tablet, or smartphone. While the EMA functionality is covered in depth in another training session, a few basics are in order so that you have a better understanding of how the entire system is designed. First and foremost, as we've already stated, and you'll hear as a recurring theme throughout all of our training, the EMA is accessible to you and your customers only after you've registered and have an APsystems EMA installer account. Next, it should be noted that you and your customers have different levels of visibility into the system's data and management functionality. While your customers can view overall system performance, you'll have the ability to query their systems at a much deeper level. Here's a picture of the YC500i and its associated cabling. It's important to note that the YC500i employs a trunk cable for AC distribution. The top cable in the photo is the AC cable, and the bottom four, two on each side of the inverter, are the DC input cables. This is a simplified, typical residential single-phase system diagram for the YC500i microinverter. As described previously, the YC500 is assigned to two PV modules, typically described as Side A and Side B. When hooking up the AC cabling, there are three conductors: brown, L1, green and yellow, ground, and then blue, neutral, which is used for the PLC communication with the ECU. A quick word on ECU placement. The ECU is plugged into a standard outlet, and you want to get it installed as close electrically as possible to the array to eliminate as many communication problems as possible. Again, as review, the maximum number of units per 230 volt, 20 amp on a circuit is 7, or a total of 14 PV modules. There are a few components needed for a successful YC500i installation, including an AC bus or trunk cable, cable end caps to seal off an open end of the trunk cable, terminal caps used to seal off an unused drop on a branch, a removal tool to remove the terminal sealing cap, and MC4 caps like those used on the YC500A for unused DC cables on the microinverter. The YC500i is compatible with both 60 and 72 cell PV modules, with a voltage range of 16 volts to a maximum of 55 volts continuous. It requires 22 volts to energize. Anything below that voltage level on the input side of things, and the inverter will not power up. Okay, with all the background information out of the way, it's time to start walking through the actual installation procedures. First step. With the racking system installed, lay out and mark on the racking where the YC500s are going to be installed, keeping in mind where the PV module junction boxes are going to be located and avoiding any other possible obstructions. Then go back and install the inverters using your marking as a guide. Do not mount the inverter where it'll be exposed to direct sunlight. Under the PV panels is preferred, where the panels are providing shade for the inverters. While the YC500 is designed to tolerate extreme heating conditions, we've found that operating in direct sunlight will quickly push those limits. Just as a note, as a safety measure and out of self-preservation, the YC500 will shut itself down when it reaches the upper limit of its operating temperature range. And it is extremely important to allow at least 2 centimeters from all surfaces of the inverter. This spacing is important for cooling airflow to reach all surfaces of the inverter. The next step is making sure that the inverters are properly grounded throughout the system. A note about grounding. The YC500i has a ground wire integrated into the cable. However, code may require an external ground. Depending on your jurisdiction, and it's always best to check with your local inspector to get their ruling on the subject, you can either use a grounding washer when attaching the inverter to the rail of a well-grounded racking system, or you can use the grounding lug on the YC500i to string code-approved wire to an appropriate system grounding location. The next step involves installing the AC branch circuit junction box in a suitable location, as close to the end of a branch of modules as possible. Make sure to wire the conductors. L1 is brown, ground or protective earth is green and yellow, and neutral is blue. With the inverters mounted on the racking system, the grounding all sorted out, and junction boxes installed in the appropriate locations, it's time to connect the microinverters together on the AC side. For the YC500i, plug the AC female connector from the microinverter into the male connector on the trunk cable. When doing so, remember the branch inverter limits. The maximum number of units per 230 volt, 20 amp on a circuit is 7, or a total of 14 PV modules. Also, a word of caution when making these connections. Do not string the AC cabling so tight that it is placing a stress on the connection points. Place the PV modules on the racking system Connect the DC leads from each of the PV panels to the microinverters, making sure that the connectors are securely snapped into place. The LED on the microinverter will flash green 3 times when DC power is first applied, indicating a successful connection. This startup indication only happens when the DC power is applied to the first side of the connected inverter. Check the DC connectors if you don't see the green startup LED flash. With the PV modules and inverters in place, and all connections thoroughly checked to make sure that they're secure, you're ready to energize the system. First, turn on the AC circuit breaker associated with each microinverter AC branch. Next, turn on the main utility grid disconnect. Note, as a safety precaution against potential islanding, the system will not start producing power for a full 5 minutes after it detects the presence of the grid. Now that the system is energized, a few words about the inverter LED indicator lights. The inverters have a number of LED indicators that are extremely useful in determining system status beyond system startup. Assuming all is good with the system once it has been energized, the LED will flash green slowly, every 10 seconds, meaning the inverter is producing power and communicating with the ECU as expected. If the LED is flashing green quickly, every 2 seconds, the inverter is producing power, but not communicating with the ECU. This is a normal condition if you have not installed an ECU as part of the system design. If, on the other hand, the ECU is part of the system design, and the inverter's LED is flashing green every 2 seconds, then you'll need to check the power line communication, PLC path, from the inverter to the ECU, as well as verify that the inverter UIDs have been correctly entered into the ECU. A flashing red LED is an indication that the inverter is not producing power. Check the DC and AC leads to be sure they are securely connected. A solid red LED indicates the inverter has detected a ground fault. For the most part, replacing the microinverters is as simple as reversing the installation process for removal and replicating it for reinstallation, with a few extra steps added to the procedure for your safety. You'll want to remove the inverter using the following steps. Step 1. De-energize the AC branch circuit by turning off the branch circuit breaker. Disconnect the AC connectors to the adjacent inverters. Next, disconnect the DC connectors from the PV modules associated with the inverter. And finally, physically remove the inverter from the rack. Follow the installation procedures we've gone over earlier in this presentation to install the replacement inverter, making sure to change the inverter UIDs in the ECU and EMA to reflect the changes you've made. A few quick words about installing the ECU before finishing this training module. As mentioned earlier, the ECU collects and stores the performance data from each of the microinverters using the power line communication, or PLC protocol, and sends it to the APsystems database via an internet connection so that the array can be monitored online. The ECU, while optional, is an essential component of the remote monitoring system that should be thought of as the gateway to the performance information that can be retrieved from each inverter and its assigned PV modules. Before jumping into the actual installation of the ECU, it's important to understand that the ECUs must be programmed with the inverter UIDs, and this can be done before, during, or after the installation. Failing to perform this part of the overall installation process will result in the ECU not being able to recognize the system's inverters. To save installation time and money, consider configuring the ECU before you head to the job site. The ECU can be easily pre-configured and registered in advance, ensuring simple plug and power operation on site as the customer's system is energized. We'll cover detailed ECU programming instructions, including this time-saving pre-configuration and registration process, in another training module that is focused entirely on the ECU setup and functionality. This concludes the YC500 microinverter and ECU installation training. Should you have any questions, please feel free to contact APsystems Technical Services at emea@apsystems.com. The next video in the APsystems Technical Training Series focuses on ECU programming and functionality. But before you leave, if you've not already done so, email APsystems Technical Services at emea@apsystems.com or fill out the registration form on the APsystems website to get yourself registered as an APsystems installer. Be ready to provide the following information. Thank you for your interest in APsystems microinverters and for viewing this training video.